Okay, Bob Jackson here, bringing you your second lecture mini-series. This lecture will be on the classification of matter. Okay, prior to classification of matter, it helps to know just a little bit about matter. What's matter? Okay, matter's anything that has mass and takes up space, and most of you have probably heard that ever since I don't know, sixth grade science. Okay, and then matter we know is can be classified in real simply like solids, liquids, and gases, and the fourth state of matter being plasma. And most of you are pretty familiar with that and know that. You realize what a solid is, and a liquid, and a gas. Plasma is somewhat mysterious to folks because you just don't see it too much unless you're a welder. A welder creates plasma every time he strikes an arc, or someone working in a electrical area. Each time they have a short or a spark, they actually see a little bit of plasma. And perhaps some people that are working in highly specialized areas to where doing some of the laser cutting and stuff like that, actually plasma cutters. Okay, but so actually when you classify matter, you start with the simplest way of classifying a matter, and that would be solids, liquids, gases, and plasma. But what we're more interested here is something that looks like this. Okay, if we take all forms of matter out there in the world around us every day, okay, we have pure substances and we have mixtures. Okay, here's your pure substances, here's mixtures. Okay, and each and every one of us are in contact with each of these each and every day of our lives. Okay, whether it's things that we're drinking, things that we're eating, things that we're using, um, are either pure substances or mixtures. Okay, like a example of a pure substance would be distilled water. Okay, now if you take tap water is not a pure substance. You can prove that pretty easily by the fact that tap water will conduct electricity pretty readily. Okay, and most people know that. But if you take distilled water won't conduct electricity at all. Okay, it's pure. It don't have the ions in it to conduct electrical charge. Okay, other things are around you each and every day that are examples like if you take iron, okay, a piece of iron. It is a pure substance. Now it'll rust. Once it starts rusting, it's no longer pure. But if I take an aluminum alloy, like we talked to baseball bats before, an alloy, any of your alloys, even if it's used in a mountain bike or metal in a car, alloys are actually mixtures of different metals. So we get the properties of each of the metals to give it the durability or ease to work with, or some of the properties like that. Pure substance, on the other hand, are always composed of just one element or one substance. Okay, now pure substances can be elements or they can be compounds. Okay, elements like iron, copper, lead, gold, silver, hydrogen, oxygen, nitrogen, all the elements that you see on the periodic table. Compounds, on the other hand, are made up of a combination of one or more elements, okay, where they are chemically combined together, like water and alcohol and sugar and salt. Okay, those are all compounds. They have more than one element in them. But compounds are pure, not just can be, they are pure. All compounds are pure substances. All elements are pure substances. And when they're pure, that means there is nothing else making up their composition other than what it is. So if it's H2O, there's nothing but H2O in that glass of water. Okay, now that's distilled water. If I have tap water is a mixture. Okay, so now then when we talk mixtures, we have two basically different types of mixtures. We have homogeneous mixtures and we have heterogeneous mixtures. Okay, a homogeneous mixture is like water. It is like milk. It is like Kool-Aid. Okay, what's the one thing that's true about each one of those? They all look the very same color and one color throughout. Okay, that's a homogeneous mixture. Homo means same. They have the same consistency throughout. They have the same and only one color throughout. Okay, alloys, metal alloys are homogeneous mixtures. That when it looks like stainless steel, it's one color all the way across, all the way through it. It's homogeneous. Heterogeneous mixtures, on the other hand, hetero is different. Okay, so it's like salt and pepper mixed together. It's like a bunch of spices mixed together that you're throwing into a pot of chili. Okay, heterogeneous, they look different colors. When you have items mixed together in a mixture and you can see each one of them, you see different colors throughout it. Italian dressing is a good example. Okay, so now then, to summarize this, we take matter, we can classify it, sure, we can classify it as solid, liquids, gases, and plasma, but if we're going to further classify it and make it a lot more meaningful in items and substances that we use every day, we actually classify it into pure substances and mixtures, which then we can break those down into pure substances can be broken down to elements and compounds. Okay, pure substances are either a type of an element or a type of a compound. Mixtures, on the other hand, are two or more different things mixed together, two or more different substances mixed together. And then you have the two different types of the mixtures, homogeneous, where they are a mixture like milk or water or Kool-Aid or a lot of types of oil, even gasoline, and then a bunch of our alloys. They all consistently look one color throughout. Whereas heterogeneous mixtures, it can be as simple as rocks and sand mixed together. It can be Italian dressing. It can be different colors of beads all thrown into one jar. It's heterogeneous. It's a mixture of different colored items mixed together. Okay, and they are different items. Okay, but all mixtures are two or more different substances mixed together. Okay, they can be elements mixed together, they can be compounds mixed together, they can be elements mixed with compounds. Okay. Now then, when we talk to solids, liquids, gases, okay, some properties with your solids that you'll see always on test is how do you further define a solid? Okay, solids are rigid. They have a fixed shape, they have a fixed volume, and I think most of you understand that. They can't be compressed very much because they're already compressed about as much as they can be. Okay, they'll vibrate, and some will vibrate better than others. Like glass doesn't vibrate very well, it's going to break. Okay, liquids, on the other hand, they're not rigid. They have no fixed shape. A liquid, I can pour it from one container to another, and it'll keep changing its shape. Okay, but in that it's not rigid like a solid. If I take a solid and dump it from one container to another, it keeps its original shape unless I kind of grind it up. Okay, now liquids do have a fixed volume. If I pour 500 milliliters of water from one glass to another, it's still 5 milliliters of water unless I give it time to evaporate some. Okay, then you go to gases. Gases are definitely not rigid. They have no fixed shape, so you take a gas and put it inside a balloon. When you blow a balloon up, you can keep on changing its shape, okay, just by pressing around on the balloon. But then gases, if I take and let the gas out of a balloon or let the gas out of any container, it ends up going everywhere. It'll take the shape of a room. It'll take the shape of a different container. It has no fixed shape. It has no fixed volume, because once you release the gas, you release the air from an air compressor. It'll take the shape of a tire because the tire holds it in there. But if I'm just shooting it out in the air, it'll take the shape of the room. Okay, there's no fixed shape to gases. Okay, Now then, here's some examples of homogeneous and heterogeneous mixtures to help you out. Here's homogeneous mixtures. We have orange juice. There's a aluminum alloy wheel. I assume it's aluminum alloy. It could be different. There's milk, homogenized milk. It is actually called homogenized milk. And then tap water. Okay, it's all one color throughout. Here's your heterogeneous mixtures. Here's some rocks and sand mixed together. Here's, it looks like Italian dressing. You shake it up, you see it's got different colors in it, different particles in it. Here's some candy. Uh, you see the different colors, the greens and the blues and the blacks and the white ones. It is heterogeneous because it has different colors in it. And then it looks like this is a package of spices here. Okay, you can see the different colors, so you would call that a heterogeneous mixture.